Hello class. In this video we'll be learning about properties of midsegments and triangles. So first we're going to actually make a midsegment. So what you do is you bisect two sides of your triangle, and those points where the bisector touches the side, those are your midpoints. And if you connect them, you have a midsegment. And so what do you think the relationship is between angles AXY and ABC? And similar AYX and ACB. Well, it looks like they are congruent, so they have the same measure. So looking at the picture, if you want to mark it, we can say that this angle is congruent to this angle. And the same thing over here. So what does this imply about the midsegment and the opposite side? If we know that these angles are congruent, those are corresponding angles, what do we know about the lines? The lines would be parallel. So segment XY is parallel to segment BC. And finally, what does the midpoint do? We've been talking about this a lot in our proofs. Midpoint divides the segment into two congruent segments. And so AX and XB are equal measures, so let's label that. And the same holds for AY and YC. So that's going to be useful in this lesson. So first, we want to prove this property of a midsegment. It has two properties that are important. It's parallel to the third side of the triangle, the side it doesn't touch, and it's also half the length of that opposite side. And to do the proof, we're going to rely on properties of parallelograms. So we're going to take the picture we already made, and we're going to extend the midsegment out here to YG. And we constructed this in a way that YG equals XY. So that's how we made this external segment. And then we connected it down to C. Now the goal is we want to show this as a parallelogram so that this top part and the bottom part will be parallel. And if we know that's parallel, and this red segment, XG, well, that's two congruent pieces. And if that's the same as BC, then each piece must be half of BC. So that's the idea here. So there's a few steps to this. First, what's the relationship here? Those measures are equal. That's how we made the construction. Okay. How are angles AYX and GYC related? Those are vertical angles, so they are equal in measure. So you can label our diagram, show they're congruent. And what about AY and YC? Well, you know Y is a midpoint by how we made this, so you know that AY and YC are equal. Right? Those are congruent pieces. And so what's the relationship between these two triangles? Why did this help us? Well, you know they're congruent because of side angle side. So now we have those congruent triangles, and that's going to help us get our parallelogram. So continuing with the same idea, what's the relationship between GC and AX? Well, these are corresponding parts of congruent triangles, so they must be congruent. So you'll say their measures are equal. Let's see. So, and since AX equals BX, what can we talk about here? Well, AX equals BX down here. So that must mean that BX equals GC. That's just substitution. Okay. And what do we know about this angle over here? AXY and CGY. Well, those are congruent because they're corresponding angles. So AXY and CGY. Okay, so we have, the idea here is, okay, well, we have this quadrilateral, and we have that a pair of opposite sides are congruent. And we already learned that if a pair of opposite sides are congruent and parallel, we have a parallelogram. So now we just want to show that these two sides are parallel. And so what can we say? Well, that's what we want to say. We want to say they're parallel, but how do we know that? What's special about these angles here? So if we extend these two sides, let's see what it looks like. So we look at the green lines that I just drew in. This angle over here, AXY, and this angle over here, CGY, those are alternate interior angles. So since the alternate interior angles are congruent, the lines are parallel. So then, what is this quadrilateral down here? It must be a parallelogram. So let me draw those little chevrons on here. Now this is parallel to this. So those two sides are parallel, and these opposite sides are also congruent, so we must have a parallelogram. So since it's a parallelogram, you know that the other pair of sides are parallel. So XY is parallel to BC. And that was part of what we wanted to prove. Right? We wanted to show that the midsegment and the opposite side are parallel, and that's what we just showed here, because we have a parallelogram. So the other part is we want to show that the midsegment is half the length of the opposite side. So what's the relationship between XG and BC? We have a parallelogram, so those measurements are equal. Right? Opposite sides of a parallelogram are equal in measure. Okay, so let's finish this up. We have YG equal to XY. And since both of these halves are the same, XG must be twice XY. Why is that true? Well, by segment addition, these two halves, add them together, you get XG. And when you substitute, you just get 2XY. Because YG and XY are the same distance. And so BC must be blank XY. Well, you know BC and XG are the same length, so it should be double XY. And that's substitution. So we just plugged in BC for XY. And we want to say this slightly differently, though. We want to say the midsegment is half the length of the opposite side. So we divide both sides by 2 here. And we get XY is half of B. I'm sorry, not just B, it should say BC. So we proved both of the statements that we wanted to show are true about midsegments. Let's go and apply those ideas now. So here, I'll figure out what is X and what's the perimeter of this triangle. Well, X is a midsegment because they show us that with the two sides, right? These pieces are congruent, so that must be a midpoint. These pieces are congruent, so that must be a midpoint. So X is going to be half of the opposite sides measure, 15. Now the perimeter here, remember perimeter means the distance around a figure on the outside. So we have a 9 here and another 9 here. Got that 30, a 10, and a 10. So you add them all together and you get 68. So that's applying the idea of the distance. Over here we have one talking about the angles and parallelism. So what must X be here? Well, X and the measure of angle E, those must be the same because the midsegment is parallel to the opposite side. So these are corresponding angles. So X is 50. And how can we find out what Y is? Well, Y is corresponding with this angle in here. And we know that the angles add up to 180 degrees in any triangle. And since that's 50, we showed before that this is 50. So it's just 180 minus 50 minus 60 is 70. So 70 degrees. In this picture, we have the midpoints already. We want to label all the sides with our congruence marks. So try that. So there's lots of correct ways to do it. Here's how I labeled mine. And we want to draw in the midsegments and label them appropriately. Now remember, the midsegment, its length is half the length of the opposite side. So, for example, XY, that's going to have the same amount of markings as SZ and as ZT. So what can we talk about the four triangles in here? What's special about them? Well, they're all congruent by side, side, side. They all have the same three pairs of sides congruent. And let's just name the correspondences. That's easy for the three triangles, kind of on the outside, I'd say, the one that's not in the middle. So you could just go RXY, etc. Now the other one, you gotta be careful with the order. If we say RX first, we gotta go ZY first. And then we go XY, that would be YX. So the order is important, so bear that in mind. Keep that in mind. And now we want a correspondence between RST and any one of the four smaller ones. A lot of ways to do this, but you want to make it so that the angles correspond in the right order. So even though there's not a congruence here, we can still make a correspondence. So for example, RXY corresponds to RST. So there's not a congruence there, but we can still say there's a correspondence. And finally, here's one we want to find X. So let's see, X is in here. And it's part of angles that form a line. So one way to think about it is to figure out what angle GIC measures. Well, we have midsegments here. Oh, I should have said that. We all have midpoints. We're assuming that. So, you know, we have corresponding angles here, right? These two correspond. And these two correspond. So the three angles, we have X, we have 40 degrees, and we have 61 degrees. So subtract those, and we end up with X is 79. 79 degrees, I should say. In this lesson, we learned properties of midsegments. Thanks for watching this video.